Hello, math humans. We're going to do 2.1 today. We're going to be looking at proportions. Our objectives are that we're going to begin looking at numerical analyses of data. So the first thing that we're going to talk about is a numerical descriptive statistic. Sometimes it looks like that's a hard word to spell. So numerical descriptive statistics are numbers that are calculated from the sample. We have a lot of definitions today used to estimate the population. So remember that oftentimes we will do a lot of calculations on the sample, and we're going to use that information to make predictions about what's going to happen for the population. And then I'll make some extra statements about the math that we're going to do versus sample versus population as we go along. So an example of a descriptive statistic could be proportions. And as we go through chapter 2, we're going to look at some of these. Proportions, locations of center, which means we're going to be looking at the average of the data. Okay, we're going to be looking at measures of spread. So 2.1 is just really an introduction into much of the rest of the chapter. And measures of spread are going to be called variability. And then we're going to be looking at percentiles. And percentiles show up often like on a standardized test score. So these are just some of the things that we're going to be looking at in chapter 2 as we talk about descriptive statistics. The first thing that we want to talk about today are proportions. Today is a nice, easy day, especially for bookwork. And these are going to be for our qualitative variables. Okay, so we can do proportions on qualitative. We can also do it on quantitative, but we're going to look at qualitative first. So an example of qualitative data would be a free throw percentage. And for those of you that are athletes, it's always interesting to think about what are your percentages, meaning that every time you walk up to the free throw line, right, what's going to be the likelihood that you're going to make that shot, right? And there's lots of things that can determine what might happen, but you work to get your percentages higher, okay? So a population proportion, and we're only going to talk about population for a little bit today. For a population proportion, that's going to be P, and it's going to be R divided by capital N. R is the number of observed successes. So if you have a statistician sitting on the sidelines in a basketball game, they are marking down every time you walk up to the line, and then they are recording your number of successes. Okay, and then N is going to be the number of trials that are observed. So this would be the total number of times that you walked up to the line to shoot a free throw. Okay, if we talk about the same basic idea, except we look at samples, a sample proportion, and it's kind of interesting in statistics, the way they talk about our variables, is called P, and we're going to put a little thingy over the top of it, and they call this P hat, okay, and it's going to be R, same R, divided by little n. So the sample proportion is still the number of observed successes, so this is still going to be your number of observed successes, but N is going to be the number of times tried. Okay, same basic idea. So both of these things are very similar. A regular P just means that we're talking about the population. P hat means that we are talking about the sample. So for the majority of this particular course, we're going to be looking at samples and not populations so we can reduce the number of variables that we're looking at. So for example number 1, you are going to ask 140 people if they prefer vanilla, gotta love ice cream, vanilla ice cream to other flavors. Okay, and 86 said yes. Okay, so a very simple proportion. So our sample proportion, and again, we're going to talk about sample for the majority of the time in this course instead of population. Population is harder to evaluate because it means that we have to have larger samples. So it's R divided by N, okay? My P hat in this case is I had 86 people said they liked vanilla, and then I had 140 people total, super simple proportion, okay, and I get 0.614, and then I could change that into a percentage, and that would be 61.4%. So then we would report that P hat is going to be 61.4%. So you've been doing these for a long time. The primary thing that we want to focus on today is there is a difference between the sample and the population proportion. For us, we are going to focus on the sample. All right, so we have one more thing to consider is, does the sample proportion allow assumptions, and we're not going to spend a lot of time on this, but we're just going to ask the question about the population proportion. So if you think about what we just did, we looked at a total of 140 people. So do you think that the opinions of 140 people and then the 86 that responded are indicative, or do they represent what the total population would believe? And so oftentimes this is a no, right? So we need to increase our sample size to be able to have an example that potentially more accurately reflects the whole population. So we have one more example for us today. Okay, so for example number 2, you are going to ask 200 people this time if they prefer Cane's, that just makes my tummy hungry, or Chick-fil-A. And I love things equally about both. 125 people are going to prefer Cane's, and then I'll make an observation about this in a moment. And then 75 are going to prefer Chick-fil-A. So please don't take these numbers to be accurate. I completely made them up. So I was just thinking of the Flag High population and what I see when you come back from lunch and what facts you have. So if I want to find my sample proportion, remember that is P hat, and it's going to be R divided by N. So my N, the total number of people that I observed was 200, okay? And then let's talk about Cane's. So I had 125. So we'll put Cane's out here, okay? So for Cane's, 125 divided by 200 is 0.625. So 62.5% prefer Cane's. Okay, and then we could talk about the 75 out of the 200. So let's just go ahead and do our Chick-fil-A, and we're going to do its sample proportion. could also call it a percentage. So the p hat would be R divided by N. So 75 preferred Chick-fil-A. I don't have that number done ahead of time. I should have, divided by our 200. And that's 0.375. 0.375. So then for our Chick-fil-A, 37.5% prefer Chick-fil-A. And again, we have to be really careful about making statements about the total population, maybe the total population of Flagstaff, because maybe my sample was more representative of the high school population or the high school sample instead of the population of Flagstaff as a whole. All right, my dears, that is it for today. I will see you soon.